Okay, guys. So our next set of examples, if you on the bottom of the front side, kind of write those two examples, or like the two types of special right triangles out, and then we'll flip it over and do some examples. I just didn't have enough room on one side. So special right triangles was our 7-4 section. And those were our two triangles, 30, 60, 90, and 45, 45, 90. Now I had some questions from students about how specific I'm going to be about when you should have radicals and when you should have decimals. This is a time I'm going to want it in simplest radical form. So I'm going to want them written with radicals. So, or it as whole numbers. So this is where you should have like 4 square roots of 3 as your answer. And it'll say that on the test, but I just want to make sure you guys are clear that I mean that. If I say write it in radical form, that I mean that. Courtney, are you with us?
No.
No. You dead? You okay? We lost you all together there. Holy cow. So one of ours is the leg, and leg square roots of 2. So this is one that I'd want your answer in simplest radical form or as a whole number. Oops, sorry. My board is really being like finicky about my driving here today.
Driving?
I always say like I'm driving the board.
No, you're not driving the
No.
board.
Controlling it.
Yes, but you're not right.
And then there's also a 30, 60, 90. Now this one you can do a little bit, both of these you can do them with trig, it's not as quick. I mean, these really you could do hopefully without having to do much calculation at all. So I shouldn't need to see a ton of work for these. So it's short, 2 times the short square roots of 3, and then we have leg square roots of 2. So we'll flip the page over when you guys are ready and talk about the examples involving those. And example 6 is the one I changed the number on it. So if you're looking at that one, we didn't change the number. So when you're ready, you guys can flip the page over. Our 2 special right triangles. Yep. Yeah, just hustle, please. Okay. So, example 5, and again, if you didn't hear me before, example 6 we changed to a 12. So example 5 is a 45, 45, 90 along with example 6. They're both 45, 45, 90s. So this is an example where you have the leg square roots of 2. So what do you know in example 5? Is there anything that you would be able to tell me right away? Yeah, Bella? Yeah, because these are both legs here. So this and this are the same. So this is also 5 square roots of 2. So we have leg. And then the hypotenuse should be what? What do you do to the leg to find the hypotenuse? Multiplied by the square root of 2. So to find u, I'm going to do the leg times the square root of 2, which in this case is 5 square root of 2 times the square root of 2. Again, you can use your calculator for this, but square root of 2 times square root of 2 should just be 2. So times 5 would give us 10. If you didn't gather, that's why I changed this next one. So otherwise they were basically the same problem. So you get 10 for your u. Now, in example 6, if I know the hypotenuse, that means I know the leg times the square root of 2. If I want to go backwards, I was multiplying the leg by the square root of 2, so instead I'm going to divide by the square root of 2. So I'm going to take 12 and divide it by the square root of 2. This is the time you want one of the calculators that simplifies your radicals. If you guys don't have one of those, please try to get one from maybe like my first hour geometry class after they've taken their test. Maybe you can do a little swap there. I don't know for sure I have enough to loan out to everybody. So 12 divided by the square root of 2, if I want to do that by hand, I have to do this. Otherwise, your calculator just simplifies this for you. It ends up being 6 square roots of 2 for both of those, because those are the lengths. The next two problems are 30, 60, 90s. So these are the ones where it's the short square roots of 3, and then 2 times the short. And so again, these are things that you'd want to study off of your yellow chart so you guys know these. And again, this would be something that's okay to write on the top of your test right away. So in number 7, which side have they given us? What's 2 square roots of 3? Which side is that? Which middle. So this is the short times the square root of 3 because it's across from the 60-degree angle. So if this is the short times the square root of 3, what do we know? Yeah, the short is just going to be 2 because it's short times the square root of 3. Take the square root of 3 out of it. So that just means the y, or the short, is just going to be 2. Once I know the short side, how do I get the other one? Times 2. So I'm going to do 2 times the short here. So 2 times 2, which gives us 4. Again, if all else fails, you can use trig for these. Just be really careful. In example 8, which side have they given us? They've actually given us the short in example 8. So this is the short side. What side do you want to find next? It doesn't really matter what's with the short. Which one? N. So this one should be short times the square root of 3. So I'm going to take lots of 3's. 3 square root of 3 and multiply it by the square root of 3. Square root of 3 times square root of 3 is just going to be 3. 3 times 3 is just going to be 9. So that's my n value. And then to go this way, I double the short. 2 times the short. So I'm just doing 2 times 3 square roots of 3. So that's just going to be 6 square roots of 3. And if this is a section you're still struggling with, stop in for AR tomorrow. Go back through this section. Go back through the notes on 7.4 and look at it again. Because when we were doing it, you guys did a good job with it. It's a lot to remember, I know. And our practice drawing those little triangles out with the short, 2 times the short square root of 3 labeled. Like, write that a bunch of different times. Write it on your, English paper if you have to in class halfway through, because you're trying to remember that as well. So I'm not expecting you to remember it forever, but for tomorrow, I want you to know it. All right, the next 3 sections really go together. So they're basically section 7.5 to 7.7, and that's our SOHCAHTOA. So our sine, cosine, and tangent. And then remembering that the inverse sine, inverse cosine, inverse tangent gives us the angles. So this finds sides, whereas this finds angles. And we label everything based off the angle we're looking for, or the angle we know. Just remembering that's where those letters come from, opposite, hypotenuse, and adjacent. And so we're going to look at the examples on the bottom there. people who didn't finish their retakes, so I was trying to remember if it was you. All right. So in these two, they ask us to find x. Again, on the test, I'll try to be really clear. If I want to know other information from you, I'll have a little blank that'll say x equals, I want to know this angle or whatever it happens to be. So in this case, they want us to find x. I'm going to label everything based off the angle I know, which is 64 degrees. So this is my opposite, hypotenuse, and adjacent. Which trig function should we use? Tangent, because they want to know the opposite, we know the adjacent, so we're going to use tangent, we want TOA. Tangent of the angle we know, which is 64, equals opposite over adjacent, O over A, so x over 16. When I'm at this point, when the x is on the top, and I'm trying to get x alone, it's being divided by 16, so instead we'll multiply each side by 16 to find our x value. And in this problem, that's all they want to know. They're not asking for any other angles, any other sides. They're just asking for that x. So we should get x is like 32.8. And that's our value of x up there. And again, look at it, make sure it makes a little bit of sense. This is the bigger angle. It should be a bigger side, so it makes sense. Example 10 is a little bit tougher because it's the opposite triangle setup, or like it's kind of flipped. The angle we know is 29. This is my opposite, and this one's my hypotenuse. So opposite and hypotenuse has to be sine. Sine of 29 equals, so it's O over H, 18 over x, and this is the kind that's a little bit tougher to solve. I like making a proportion. So where I cross multiply and set these equal. Because then to get x alone, I know I have to divide by the sine of 29. So 18 divided by the sine of 29 is going to be my x value, which looks like it should be the longest side. So I got like 37.1. And then the next two problems ask us to find missing angles. Kind of the two scenarios for that. So to find our missing angles, this first one doesn't give us a lot of options. Because this is the unknown, this is the opposite, this is the hypotenuse. And I'm trying to find that angle. Those are the only two sides I know. I can find the third side, but it doesn't ask for it. So I'm just going to use so. But I don't know the angle this time. So sine of question mark equals O over H. So I have question mark equals the inverse sine of 31 over 60. So how I solve for that angle is I do the inverse sine of that proportion or that ratio. And I believe it's like a 31-degree angle. Yeah, it's like 31.1 degrees. And then the last one gives you all three sides, so we have to determine which one we want to use. I'll try to just use cosines. We haven't used it recently yet. So this is the opposite, hypotenuse, and then adjacent. Again, because I can use whatever one I want, I'm going to use cosine this time. Adjacent and hypotenuse. So cosine of question mark equals adjacent over hypotenuse. So we're doing the inverse cosine of 48 over 60. So I got like 36.9 for our angle. So again, if you didn't hear me before, the homework doesn't start till number 5, instead just one question off. And then work on this during class here today. Bring questions tomorrow. We'll do questions before we do our test then.